We have a philosophy at Imperas that nobody would tape out a chip without simulation. Any investment in a prototype, you heavily simulate the RTL before you tape out a device. We believe the same should apply to software. You should simulate all your software before you complete your product. And in today's environment, where we're doing many updates, we think you should simulate all your software, particularly as you do updates and field, simulate before you deploy. We're around for 12 years. We're based on simulators, reference models. We work with the RISC-V industry. So we build these reference models. Around those, you can build a virtual platform with periphery to emulate your device. So we do simulation, which then allows you to plug in debug and analysis tools. This gives you great visibility to the operation of your system. And this can be done ahead of the availability of hardware. So as you're developing your chip, you're developing your board, you're developing your system, you can build a virtual platform which gives you a full way to develop your software ahead of schedule. This is great. So I'll talk a little bit about verification. When you build a new processor with RISC-V, RISC-V has many extensions. You can add custom instructions. There is much flexibility with an open ISO. So with a reference model, we can now test your RTL. So the RTL you develop for your new processor, with a system Verilog test bench, we can insert the reference model for Imperas. Run the same test suites, the same instructions on both the RTL and the reference model, and then do a comparison. This is a great way to test the processor operation. That's just a brief update. We have a more extensive talk, and you can join us for our booths afterwards if you want to hear about verification. So the key for all of this is a reference model. For software development, for processor verification, RISC-V is an open ISO. That means you can tune any of the standard extensions, many options, many configurations, and add custom instructions. So when we build a model of a processor, we have a checklist of all the details that you might want to include and consider. There's over 250 parameters that you might want to tune for your particular processor, which shows really the strength of RISC-V. There are other processors available, but they're off the shelf. They may not fit exactly your application. The advantage of RISC-V is you can choose exactly the features that you need to optimize your application. And this is why people believe RISC-V has a great potential. Within our reference model, we support all of the ratified specifications. There's a lot of details here, but we also support some of the earlier drafts. As you develop a project, you might go from an early draft to a more released version of the specification, and you might tape out a chip maybe 1 year from now. So it's very important to be able to tune your model to the exact specification that you're interested in. Now, having got a very good reference model, if you want to add custom instructions, there's a potential as you edit the model of making an unintended error, introducing something that you didn't expect. So we've set out a structure with a side companion library. So you have the fully qualified reference model, and then you can insert next to it your custom instruction without any risk of contaminating the original model. This gives you a good sense of security as you develop your whole system. So what is a virtual platform? A virtual platform is a way of simulating hardware. So you have a processor, and then you have periphery elements. But also in any system, you have microphones, cameras, keyboards. These can be used through the host machine. So you can build your whole environment. You can use the Ethernet port. You can build a whole emulation of your system in a virtual platform. Now you can boot an OS. So you could boot Linux or an RTOS. Then you could write your application on top of your OS. The debug and analysis tools help you look at the boot process, the firmware, the OS, and the application at all levels of the software without changing any of your original code. So if you're doing a high reliability or a medical application, you can run your exact binary on the virtual platform. Another use case is if you're developing an OS port or an RTOS bring up. If you're using a real board, you don't have visibility to the first stages of the boot process. You You can't write a printf if you don't have a print terminal. With this system, we're doing all the debug and analysis through the virtual platform. So right from the beginning, the very early boot code, you can see all of the progress. This really saves a lot of development time. What we would hope to achieve is good working software before silicon arrives. So when your prototype comes back, you're able to run these early software. Okay. The Imperas Environment. Around the virtual platform, we have all the tools for the debug and analysis. This allows you to introspect and optimize and analyze all of your software. In the case of custom instructions, you can profile your code and look for hotspots and look for areas that could be developed as a custom instruction. This is a good way to trade off what's the balance. Too much dedicated hardware might become inflexible. So you need to look at what are the optional custom instructions you might want to add. So in a modern software environment, you want to do continuous integration, possibly with a group team. As you know, over the last couple of years, we've all been working remotely. So a virtual platform allows you to share your resources with remote teams or even other companies in a continuous development and integration flow. Right, this is the headline. So with Quake, this is a game that some of you may have played a while ago. The code is now open source. So we can take that code and optimize it and run it on a virtual platform. So, what is a virtual platform? We've built a very simple RISC model which incorporates the speakers and the keyboard from the host machine. Obviously here I only have one display. In a normal development environment, you would have multiple displays. So you would tune the simulator to output to one display while you're looking at the trace and the log files and the operation of your debug in another display. So this shows you some of the working environment you would set up around the debug analysis of a real software project. The key thing about this is running on a virtual platform, but it is interactive. So you can have keyboard control and sound. So some people have talked about early prototypes, maybe use other technologies like an FPGA or some other approach. They run very slowly. So if your application requires that interaction, that real-time analysis, this is a very fast solution. So I'll give you a brief demo and hopefully the sound is going to work here. You can hear that. So this is running the Quake code on a virtual platform with sound, and it's synchronized with the events. It's a bit scary. Okay. So that was a short demo, but you can see here on the log files, that was 119 billion instructions. So as I said earlier, when we talk about verification, you're looking at instruction level accuracy to do that comparison with the reference model. This is a very vast simulation that allows you to do software development in virtual real time. So really, just to sum up here, using virtual platforms help you develop your software before you have hardware. This lets you try out system architecture, look at custom instructions, optimize your software, and then complete your development to compress schedules. It's not bad. We supply multiprocessor debug, the analysis and verification tools. We've got a fast simulator, many processor models and platforms. In addition to RISC-V, we also support 12 ISAs, so you can have a heterogeneous design. And virtual platforms provide this great working environment to shift left to get your project out early. Right, so my name's Kevin McDermott. We have a website for Imperas.com is our commercial products. OVP World is our open source models. And if you download the evaluation, this will now have the Quake demo in the next release. So you can play with it at home in your own time. Have fun, and I'll be happy to answer any questions. Thank you.